today. We have to develop fast. We have to reach targets, TRLs, grow, get our tech to space. That's our goal. We will not be bound to one country. That's one point that we want to make today as well. And we'll go where the opportunity is the best over the next months and years. And we're open to, just discussing and socializing with the guys that want us the most.
Hey, Space Watchers, this is Space Cafe Radio, your channel about trends, awesome events, and interesting people in the space sector. This is a very exciting episode, as I have the chance to talk in depth with people that understand propulsion, electrical space propulsion. Just a few days before the Space Tech Expo in Bremen, I sat down together with a team of Neutron Star Systems, with Manuel La Rosa Betancourt, with Dr. Michael Winter, and with Robin LeBeau. As these talks develop sometimes in an unexpected direction, we talked about technology, entrepreneurship, the market, but also about Germany as a hosting country to the company. At the end of our conversation, we spoke about something I was very curious to know more about, nuclear propulsion. I'm Torsten, publisher at SpaceWatch.Global. I would also like to thank Neutron Star Systems for their support in producing this episode. Lean back and enjoy. Hey, Space Watchers! I had the great honor to record a Space Cafe clip with Manuel La Rosa Betancourt during the German Space Congress in Berlin in October. This short interview needed more input and context, and so I'm very happy to have the chance to talk today again to Manuel, the CEO, and two of his new team members, Dr. Michael Winter, Chief Technology Officer, and Robin LeBeau, the Operation Manager at Neutron Star Systems and responsible for investors' relations. So guys, welcome to the show. How are you doing today?
Hello, Torsten. Many thanks again for having us and giving us the chance to tell our story. I'm really happy to have with me today Michael and Robin, who have joined the team and are here to help us to transition into NSS new phase.
That's cool. So, Michael and Robin, you joined recently Neutron Star System, one of my personal hidden gem in the German space ecosystem. So, how is it going?
Thanks, Torsten. I joined Neutron Star Systems in June this year. Got right into the hot water with some projects we are running, which started at that time. I got my PhD from the University of Stuttgart, worked there until 2008 on electric propulsion and re-entry technology and re-entry plasma diagnostics. And then I left Germany and went to the United States to join NASA Ames for a while to do re-entry plasma diagnostics. I had the opportunity to play professor for a while at the University of Kentucky for 8 years, had my own research lab on the same topics, and joined Momento Space in California after that for 2 years to work on microwave electrothermal propulsion with water as a propellant. And then the opportunity to join NSS came. And I'm really excited about that because the first thing I ever did in science as an undergrad student was actually working on MPD research. MPDs are magnetoplasmodynamic thrusters. And commercializing these applied field MPDs is actually full circle for me, which I'm very passionate about. It's a great opportunity, thanks to the work with our partners and the support by the European Innovation Council and the European Space Agency, and that is highly appreciated.
Sounds very impressive. And welcome back to Germany.
Thank you.
Robin, over to you. How can you top that? Tell us more about you. Why Neutron Star Systems for you?
For me, so the background is economics and management. I studied in Milan for a few years. When I was in Milan, I built a company and sold my shares after 2 years as I was graduating. Later on, I wanted to focus, after a few steps in startups left and right, I wanted to focus on fundraising. So I built a consulting firm to help startups to raise funds. And I've helped about 30 startups in the last 3 years to raise about 25 million in total, compounded of all of them. In that experience, I joined Starburst as well as a fundraising mentor, which was about a year and a half ago, especially for the Blast Accelerator, which has been very fun. And as I'm very passionate about space since a few years, I'm going to say 10, I wanted to join fully operationally one of the startups that, I really looked up to. And that one was Neutron Star Systems. They gave me a chance to help them join the future. So I'm here for that, especially on the fundraising side, but so many more hats that I'm wearing all the time. And it's been fun so far. It's been a month, but everything is super exciting. And I get a very cool feedback from the market as we were in Sevilla in the Space Week in the last few days. And yeah, I feel like there is a lot to do and a lot more to do. So as I saw the opportunity was there, I jumped on it. And there was no question asked.
Cool. Sounds great. Manuel, back to you. You have a wonderful new team now, and you by yourself, you started in the space industry, I think a few years back. And I'm quite sure that all of your work with your own company now is bootstrap. But tell us your story.
Thank you, Torsten. Let's be precise. It has been 7 years. So we founded the company in 2019, and time we joined, we have been working already on the stealth mode with the University of Stuttgart. We prepared one of our first Supreme proposals, which we submitted in March 2019, and which, by the way, was rejected. From that time on, it has been a long list of successes and also failures. Among them, we have been able to achieve 2 contracts with the European Space Agency. Also, we won our first European Innovation Council Pathfinder project called MEAS, which stands for Magnetohydrodynamic Enhanced Entry System for Space Transportation. And in 2021, after founding in Germany, we decided to seek for better opportunities in the United States of America. And we went to the Catalyst Accelerator in Colorado Springs, where we had a really great time engaging with the U.S. Department of Defense and the United States Space Force, and ending making the Hyperspace Challenge. And after that, we won our first contract with the Air Force Research Lab. 2022 was a tough year for us. We were bootstrapping, runway was going down. And at that time, 2 of our co-founders stepped out, and I remained alone in the company trying to turn off the light when the time comes. But that time didn't come. Indeed, what it came was that we won another European Innovation Council project, which is called Supreme, after the 3rd time. And after that, we also won European Space Agency project, where we're working on the 100 kilowatts AF MPD thruster. And we have revamped the team again. We have now a team of 12 people. And I'm looking forward to the new phase that is coming.
Help me a bit to structure this market. So electrical propulsion sounds exciting. That's a field you're working on, but it's not that exotic anymore. Many companies are in this field. So how does the propulsion market look like in Europe or the world? And why is Neutron Star Systems different from the others? I think I'm asking Michael for this question.
Yes, that's a good question, actually. Yes, electric propulsion is no longer that exotic. There's a wide field of different technologies, and many of them are flying. It's starting with resistor jets, which are electrothermal thrusters. Basically, the fuel is heated through a resistor where we heat up a tungsten body or wire and transfer heat to the working gas. You can drive that up by using a discharge in arc jets, and you get higher temperatures and then higher exit velocities. Now, the exit velocity is important because you want to transfer an impulse to the spacecraft, which means it's mass times velocity. So low velocity and high mass flow of gas, or high velocity and a low mass flow of gas, will basically provide the same specific impulse. But the latter provides a more efficient use of the fuel. So higher payload capability is achieved if you get higher exhaust velocities, or you can achieve a longer lifetime, or however you want to calculate. So the highest performing electric propulsion systems to date are Hall-effect thrusters and gridded ion thrusters, and they use electrostatic acceleration rather than thermally expanding the gas. Now, there's a number of companies out there who provide these propulsion systems, at least 100 established companies, and then there's a lot of startups coming up working on these different technologies, driving or improving the one or the other. If we compare that, the maximum exit velocity for chemical propulsion is like the H2 plus O2 combustion, and it's about 4.5 kilometers a second. Now, an arc jet can get up to 12 kilometers a second. I've seen that model, which even went up to 20. Hall-effect thrusters typically are 25 to 30, and gridded ion thrusters get up to 60 kilometers. So these are established technologies, some of them commercially available. And the good question is, why do we want another one? the AFMPD. So the applied field magnetic plasma dynamics thrusters are performance-wise in between the Hall effect and the gridded iron thrusters. As far as this exit velocity is concerned, completely competitive to those thrusters. But there's limitations to every propulsion system because of its physical nature. And Hall effect and iron thrusters work best with propellants like xenon or krypton. And that's where they reach their high performance values and high efficiencies. These propellants are expensive. They have supply chain issues. So people are looking around for other propellants for these thrusters. Now, our MPD thruster is completely happy with argon, which is cheap and easily available, no supply chain issues at all. And actually even more, there's experimental evidence that you can operate these applied field MPDs with ammonia, for instance, with still great performance, which is not possible with the other thrusters. And that is important because ammonia is a decomposition product of hydrazine, and hydrazine is a very popular monopropellant with large tradition and use in space for chemical thrusters. And there is another advantage that we can provide with our MPDs. We could run the MPD in parallel to a chemical thruster with hydrazine without having to add tanks or propellant feed system and so on. And that would be combine the best of two worlds, like the very highly efficient, mass efficient use of the propellant in the MPD thruster and the higher thrust and faster response time of the chemical propulsion unit. And I think this has huge system engineering benefits to the industry and might be a game changer to some degree. Lastly, MPD thrusters scale very nicely with power. At the moment, we are not really using high power electric propulsion systems in space, but for future applications, this is actually clearly on the radar. So yes, we believe that applied field MPD thrusters do have a bright future in space propulsion.
Thank you, Michael. I can hear that you work as a professor. I was listening really with huge excitement, especially as I am an engineer, but I'm not an engineer in this field. Let me ask Manuel for a bit more clarification. If you break it down, what is unique in this technology, in your technology?
Yes, I guess that you want the pitch-like answer. You got the scientific answer and the technological answer. We have three main differentiators, okay? So one of them is scalability, as Michael mentioned. And on that scalability, we could say that out of that more or less 100 electric propulsion companies you have in the market, we belong to that 10% of companies that are in the capability to offer thrusters that can scale beyond 20 kilowatts, which is, to put everyone into context, the kind of power you need for a 2 to 4 tons geocommunication satellite, just to give you a reference point. Then the propellant flexibility.
Is anyone building these big satellites anymore?
That's a good question. There has been a move and a transition in the market to more shorter and small satellites. I think that now payloads that no more than 2 tons are aimed for this type of satellites, but still, you still need a lot of power to move them around, not because of the payload or the weight, but because of the transmission power that you need to have if you want to broadcast and transmit communications to a large public or a large number of users. Following the propellant flexibility, Michael spoke about argon and ammonia. We can also operate with xenon, but xenon is now prohibitively expensive propellant these days. And also main sources are coming from Ukraine and Russia. We can also operate with other propellants like nitrogen, ammonia, as mentioned before. Krypton is another one. Hydrogen can be used in this type of thrusters. And this is interesting because you can combine these thrusters in hybrid chemical electric architectures to provide maneuverability. And maneuverability is the kind of value in space these days because that's exactly what you need to navigate, especially in contested environments like LEO, with all the debris moving around. you have a thruster that allows you to build a system that can be able to provide collision avoidance maneuvers, that can provide rendezvous maneuvers, and all in one system. And last but not least, these thrusters are enabled by something that we call high temperature superconductors, which are materials that can carry power without losses. And this is tremendously important because every time that you want to scale power in space, you have a dilemma. You have to increase the mass, you have to increase the weight, the volume, and also the inefficiency that is coming out of that. So the larger your system, the larger is going to be also the power heat losses that you're going to experience. And just to give you an example, an airplane, when it's taking off, needs 40 megawatts of power, and it can generate up to 200 kilowatt of power heat losses. All that power get lost. On a nutshell, we are scalable, we are propellant flexible, we are maneuverable. And that allows us to cover a very wide range of missions that goes from small satellites, 250, 450 kilo payload, up to several tons for cargo transfers to the moon and Mars.
Let me ask the professor again. Michael, what is the current degree of maturity of the technology that you're using?
So traditionally, Manuel mentioned the high-temperature superconductor coils, which are enabling technology because in the past, permanent magnets have been used with the penalty of being very heavy, very unflexible. Also, permanent magnets eventually will lose their magnetism. So those were the first steps. Actually, there was a Japanese flight demonstration with permanent magnet back in the 90s. Nowadays, this superconductor technology in combination with light field MPD thrusters has a couple of places in the world where it's developed. There are activities in China, in Russia, New Zealand is a big player, and basically us. And none of us players has yet managed to produce a flight model of this technology. We are working on that. And Manuel already described the scenario of power classes that we're aiming at. We currently with Supreme, we are aiming at a 5 kilowatt thruster, which is based on a 100 kilowatt thruster engineering model that is run at the University of Stuttgart. And they have generated a vast database of experimental performance data of this thruster with water-cooled coils, water-cooled anode, and so on. And it is very promising. So if I say 5 kilowatt and downscaling from this 100 kilowatt version, the IRS thruster can actually very efficiently run between 25 kilowatt and 100 kilowatt. So we expect the Supreme to have the same flexibility. So 5 kilowatt nominal probably be able to have some flexibility in there, which makes it good for commercialization. So we are in the design process. PDR is going to be by the end of this year. By mid of next year, we plan on having a full design and start building the thruster and testing it again together with University of Stuttgart in 2025. So that is the way we want to go. At that point, we will have a prototype thruster. And now the next step is going to be an in-orbit demonstration, which, if everything goes well, we plan for end of 2026 or in 2027. That would be the ambitious schedule for that.
Great. Robin, how do you plan to bring this technology to the market? It's not off-the-shelf technology. It's not very common use technology. So there is a very niche market. How do you address this market?
Actually, the market in terms of size and sizing is not that niche. It's just the way to access it that's a bit difficult, because when you sell thrusters for a few millions, then it becomes a very good opportunity for investors fast, right? You don't need a lot of contracts to make multi-million dollars a year in revenues, which is great. The idea now is we have basically two big steps to achieve by the end of the year already. In the next 6 weeks, we'll raise some funds from private investors, which will be disclosed early in December. So we are now socializing with investors and taking the temperature of the market for that. And secondly, we are reaching PDRs and milestones for the tech side. One of them is going to be also early December. The idea now is to capitalize on all the letter of intent, letter of endorsements we got from our partners and future partners. And the idea will be to get one or a few of them to help us make the demonstration in space. So the IOD, the in-orbit demonstration. We are speaking with large companies like Sierra Space, Northrop Grumman, ISI, OHB, Orbit Fab. We have a lot of contacts. These guys need this space avoidance, this maneuverability, this new technology. So that's what we work on, and we take things step by step, month over month, and we keep growing on the tech side and with our future investors, hopefully.
Manuel, spacecraft satellites getting bigger again. Space tugs are coming up, in-space satellite servicing, assembly and manufacturing is on the horizon, and you guys are also very active in Converse and in other groups. How is your technology positioned for this near-term market?
As Michael previously explained, we are building a 5 kilowatt thruster, which is the sweet spot at the moment for power, because that allows us to address a particular type of spacecraft that goes between 400 kilos and up to 1.5 tons of weight. And this is the next coming market in orbit servicing, assembly, and manufacturing. And here's the way we see it. You mentioned this is a niche market. I don't think so. If it is a niche market, it's a perception that is a niche. And as Robin mentioned before, the access is kind of niche and difficult. However, we see the future coming that is going to be coming with larger and more capable and more power-hungry spacecraft. And that's where we want to position ourselves. We envision a space economy in 2030, with at least 50,000 satellites in orbit. Some people say 100,000. Let's go with the conservative number, 50,000. Let's go with an even more conservative number. Let's go with 30,000. We estimate that an interesting portion of this market is going to be dedicated to this type of payload class, where we can play an important role with our 5 kilowatt thruster operated on argon, which is a propellant 1,000 times cheaper than the state of the art, which is xenon. That's where we see ourselves coming. And beyond that, we see huge demand for cargo transfer capabilities from LEO to the moon, and also from LEO to other orbits like GEO or XGEO. We're quite confident that the market is going to go into that direction.
If I might add, but that doesn't account for the platforms, the potential space hotels, and all these will come eventually, and we'll need thrusters, and we'll need maneuverability, and we'll need avoidance. And that's been a big topic in the last few days at the Space Week. Avoidance is key. And there are a lot of services for SST right now. Thrusters has canceled the issue and can help. So the market will flourish for that later on. The tech is still not there.
Let's talk about the real challenges. You're a company in Germany. You're a German SME. So, Manuel, what are the challenges that have been on your way and the potential challenges ahead? Now with our new strategy, everything is paved and everyone is happy in the German space ecosystem.
Stay with us. We'll be right back.
Moving is right up there with death and divorce in the Stress Olympics. But fear not. Turn that box of woes into a crate of woes with moving tips in the Life Beyond Boxes podcast with Premium Q Moving. Dive into the world of hassle-free moves, learn tips and tricks to save on cash and your sanity. Say goodbye to those moving meltdowns and hello to the smooth sailings, or should we say smooth movings? Tune into Life Beyond Boxes with Premium Q Moving on lifebeyondboxes.com, or find us on your favorite podcast platform, and with us, unpack the secrets to a stress-free move.
Torsten, you have a great quality for making difficult questions. I told you that in the past interview, and again, oops, you did it again. Listen, operating in Germany remains a very challenging endeavor. It is difficult. It is a risk-averse environment. It's a complicated environment to operate for smaller startups, especially disruptive, innovative startups like ours. But we're confident that with the partners we have and the contracts we have with the European Innovation Council and the European Space Agency, we can capitalize in this traction to make this technology fly. Germany remains at a strategy level a huge question mark for us. But I think that the challenges we have in the past was getting our voice heard. Now we achieve that. And now what we need to do is build our capability demonstrate our MVP and show the market that we can build this and fly it.
Yeah, just to add to the point, it's a super interesting question. Once we talked about the strategy and the fact that Germany, these days at least, are still, and there are some successes. We've seen successes in space, like ISA, aerospace, and so on. For some reason, early on, with long timelines, with TRLs coming, with the tech steps to take on, and it's still far away. We said that the IOD is going to be in 2026, right? Hopefully earlier, but we're not going to promise investors anything else, and we want to deliver on that. In Germany, we feel like early on, and that might be the case for just private equity or VC world in general, that it's difficult to get backing early on. The strategy for us will be any way to go for business angels. Now the idea is to leverage the capital we get from angel investors and get support from states. France, for example, France, as the ecosystem is as it is today, is backing startups that are very risky, and it pays off. It was a very big politic of Emmanuel Macron in the last few years, developing the French tech, developing BPI France, launching the space tickets in France. The leverage you can get with investors and with equity in France is different and non-comparable to anywhere in Europe. And that's a fact today. We have to develop fast. We have to reach targets, TRLs, grow, get our tech to space. That's our goal. We will not be bound to one country. That's one point that we want to make today as well. And we'll go where the opportunity is the best over the next months and years. And we're open to, just discussing and socializing with the guys that want us the most.
So you're operating in a true European spirit. Let's put it that way.
Absolutely. And that's why the EIC has been so great for us. The Pathfinder and the transition, they provide what Europe is all about, which is a collaboration and helping the guys that are moving towards the future. And we don't want to be bound to one country. We want to be bound to Europe and provide these technologies to Europe, because China, Russia, they're here to get this market as well. And we want to have our word to say.
We have to come slowly to an end. Manuel, what are the lessons learned for the next generation of SMEs that are about to come? Is there anything you want to hand over to the next gen?
To the next generation of SME entrepreneurs in Germany, I will just quote my good friend Gilles Ravin. He has been fundamental on advising and providing mentoring to me and the members of my team. Keep walking. Entrepreneurs need to learn to keep a cool head. As a born Venezuelan, that has been quite difficult for me. But keeping a cool head, having the right amount of badass attitude is needed sometimes. And in most extreme cases, sometimes you will have to bang the table with your fist if you want to get your ideas and voice heard. Be prepared for that and keep walking. That's my lesson learned.
Great advice. As I have the chance to talk here in our wonderful interview to propulsion experts, I need to ask you the nuclear question. So 2 questions actually. How important and how needed is that for the future? And is that something that is also in the making in Germany or in Europe? Or is that too futuristic, too dangerous for us here? As we all know, Germany switched off its nuclear power plants years ago. So what is your view on nuclear propulsion?
I'm going to give you one short sentence and I will pass this to Michael, because I think he's more entitled to provide an answer to this question. Nuclear power is a reality. There is a strong push in the United States. There are grants, there are contracts, there are initiatives pushed by DARPA, by NASA, etc. I think that if we want to keep on the race for high-powered spacecraft market, we're going to need nuclear power. Regarding Europe, etc., I think I will just pass this to Michael and see what he can add to it.
Well, actually, you made a good point and you already mentioned most of the important facts. Nuclear power in space in terms of small reactors, we're not talking about nuclear thermal propulsion, I think, has been coming in waves over the last decades. The topic was brought up multiple times. Projects were started and ended again. I do think it will come eventually. And in particular, if we feel the real need for high power propulsion. If you want to go to Mars with electric propulsion, there's no real way to use existing power technology to do that. Solar cells can only get you that far. Imagine the solar cells of the International Space Station and what power are they generating? About 200 kilowatts or something. That is not even close to projections for electric propulsion that is needed to bring us to Mars, which will be on the order of megawatts in power. So there is no other way, if we want to pursue that way, that eventually nuclear propulsion is going to go to space.
Is Europe, is Germany touching it?
I had a point as well. We've seen how Germany loves nuclear in the last few years. I think if it comes from somewhere, it's going to come from France.
Okay.
There we go again. I think basically, if we have learned anything from history, it's going to be the players who are more doing than planning who are going to do that. If I would have to pick, I would say there's going to be a Russian nuclear reactor at some point or a Chinese one, because there's more driving forces there and less obsession with regulations, which in this case might be actually a good thing, because on the other hand, you said it, nuclear power is nothing that you want to just play with without having the clear regulations. But this is the current situation, I think, and we will have it eventually.
Okay.
Where will it come from? That's the gamble.
Great. Thank you very much for your assessment. It's very helpful and very useful for us. So last questions. What comes next to you, Manuel?
We keep bootstrapping, and now the ball will go to Robin, because now he has to help us to get an investor. But that's what is coming, is our PDR, our CDR, reaching our technical milestones and our investor readiness milestones, so we can make this fly and support and contribute to Europe's non-dependence and leadership in space. That's what we're here for.
Yeah. So what comes next is definitely, it's a pleasure to raise funds for a company like that, or at least start socializing with investors, as the roadshow is not started yet. We have a lot going on with Neutron Star Systems. The tech is really promising. There are a lot of projects with Europe, with the EIC. We just can't wait to deliver on that and reach our goals on the tech side. And for that, of course, we need to raise a bit of funding. It's not going to be 10 million. It's going to be just finding the investors that trust us and that we trust to provide something to us, be it smart investors, provide smart money, give us the advice from their past experiences, and help us pave the way for the future of electric propulsion and potentially hybrid models, as we spoke about. So the next step is that, speaking to the right people and reaching the goals on the tech side and leveraging our contacts with existing partners and the ones to come.
Michael?
Actually, one point that we haven't spoken about yet is the one that's most important for me at the moment, and that means delivering what we promised. We have the chance now to build these systems, and we're going to do everything to follow our milestones and projects to finally build hardware and to show the world that we are capable of bringing this technology to life. That is my main role in the next years.
Manuel, some last word?
We have our demo day on the 5th of December, which is a demo day taking place within the Expreneurs Accelerator program of Unternehmertum in Munich. That's going to be the beginning of potentially our roadshow for raising money. And I'm looking forward to that day and to deliver and for the next months to come. The next months are going to be fundamental for us, for our existence. And we're at crunch time. You ask me what is going to come ahead. It's just work, and more work.
Okay. I picked it up from your website and I love this. The future is electric. Thank you all for your time. I wish you good luck, and we will keep following you in your great and inspirational work. Thank you very much, guys.
Thanks a lot for your time.
Thanks, Torsten.
Thanks a lot. And the future is electric indeed. Thank you.
Thank you. If you have further questions, reach out to us at radio@SpaceWatch.Global. If you like these or other episodes of Space Café Radio, leave us a rating on your preferred podcast platform. It is the currency of today. And if you want to stay on the pulse of the space industry, please visit our website at www.spacewatch.global and subscribe to our newsletters. And of course, don't forget to become a Space Watcher. I'm Torsten Kriening, publisher at SpaceWatch.Global, your independent perspective on space.